Hello, so in this video we're going to continue our work with differentiating, and again we're going to be referring to the power rule, okay, which if you watched the last few videos, you looked at the last few sections. The power rule says if you have a power of x, so x to the power of n as a function or whatever, if we have x to the n, then the derivative of this is going to be nx to the n minus 1. So we bring the power to the front, so it's nx, and then we knock one off the power, right? So as a very brief example, we saw that, for example, if f of x was 2x squared, then the derivative, the power comes to the front, so it'd be 2 times 2, which would be 4, and then 4x, and then knock 1 off the power, 2 minus 1, which is 1. And that's just x, so that's the derivative, okay? What we're going to look at in this section is basically the same thing, but the idea being that we can add derivatives together. So if we had y equal to two functions, f of x and g of x, so we have two terms of x, right? We have the first term here, f of x, and then another term of x, g of x. Then if we want to compute the derivative of the whole expression, which is y, then dy dx is going to be we're going to differentiate it term by term. So it'd be the differential of f of x at f dash of x, and then we add the derivative of g of x, okay? So basically what this is saying essentially is if you have two terms of x, then we differentiate them individually, okay? It's one of those things that seems that's easier than it looks, okay? But the idea is we can add derivatives together, okay? So we're going to jump into some examples then. So with that in mind, we need to find dy dx given that y equals, firstly, 4x cubed add 2x. Now y is equal to this, so then the derivative dy dx. So then what we're going to do is we bring the power to the front, so 4x cubed, we bring 3 to the front, so it'd be 4 times 3, which should be 12x. Then we knock 1 off the power, so it'd be 2, okay? 12x squared. Then 2x, well, we saw last time 2x, that differentiates to just 2, because x goes to 1, right? So x differentiates to 1, so we're just left with 2. Okay, part B, we have x cubed, add x squared, minus x to the half, right? So then the derivative, well, what we're going to do then, we're going to bring the power to the front, so it's going to be 3x, and then squared to the power 2, right? Because 3 take away 1 is 2. So we knock 1 off the power here. Then we differentiate the x squared term, so that'd be plus 2x, right? Then minus x to the half. That's going to be minus, we bring the half to the front, so it'd be minus a half x. And then if we knock 1 off the power, a half minus 1, that's minus a half, okay? And there we are, that's my derivative. Part C, we have y is equal to a third x to the half, add 4x squared. Then the derivative is going to be, well, again, it's going to be the third. Then we're going to bring the half to the front, so then a half will be times by a third. And then x then, and then if we knock 1 off the power, a half minus 1, that's going to be minus a half. And so then we can simplify, and then we differentiate the 4x squared, right? So that's differentiating this term of x. Then we can differentiate 4x squared. So add 4x squared, that would differentiate to 8x, okay? Because the 2 goes to the front again, so 4 times 2, which is 8x. Okay, so we can simplify some things. We can expand this bracket here. So that would be a third times a half, that'd be a sixth, x to the minus a half, add 8x there, okay. Right, so that's it. If you're a bit confused by that, we did look at more simpler examples. a few videos ago when we looked at we broke it down in more detail. But the idea is, at this point, hopefully you're kind of familiar with the power rule, so we really should be at this point starting to do it quite quickly. Okay, so you'll be able to differentiate with ease. Okay, but again, if you need it a bit more slowed down, if you're a bit unsure, please watch my older videos on the power rule. Okay, right, now we do need to differentiate these expressions. So differentiate, so let's say y is equal to 1 over 4 root x. Right, what we can do then, we need to use index laws, right, to get it in the form x to the power of n. Okay, we have root x at the moment, but what can we do? Well, first of all, I can rewrite this root x as x to the half, so 1 over 4x to the half. What we can then do is we can factor out. What we can say is this is equivalent then to a quarter times 1 over x to the half, right? Hopefully you can see that. So we're basically factoring out a quarter out of this, right? So we're left with 1 over x to the half. Then what we can do is we can rewrite this x to the half as a negative power, because it's a reciprocal, right? What's going on here is a reciprocal, because then that'd be x to the minus a half, and so then we're left with a quarter x to the minus a half. Now we're in a position we can differentiate, okay, using the power rule. So therefore, if we differentiate it, it's going to be a quarter, and then the power is brought to the front, so that be times by minus a half x, and then we knock one off, so minus a half and minus 1, that'd be minus 3 over 2. Okay, then we can do some further simplification. A quarter times minus a half is minus an eighth, x to the minus 3 over 2. Okay, cool. Now at this point, if you wanted to, you could maybe evaluate this index. So we have negative 3 over 2. You could say that's minus an eighth of 1 over x to the 3 over 2, and then maybe go from there. You don't have to. If it doesn't say to write your answer in a particular form, so here the question literally just said differentiate. It's fine as long as you get the answer. It doesn't matter what form you leave it in. You can leave it in this form. You don't need to do any more simplifications with the indices. That's completely fine. Part B, we now have y is x cubed times 3x plus 1. Well, again, I can only add x's together. What's going on here is I'm timesing two bunches of x's together. I need to expand the bracket, right? So y is then going to be x cubed times 3x. That'd be 3x to the 4. Add x cubed. Now I'm in a position I can now differentiate each term individually. Okay. So if I do that, then dy dx. So 3x to the 4 times. So the 4 brought to the front. That's going to be 3 times 4, which is 12. X. Then we knock one off the power, so 4 minus 1 is 3. Then we differentiate x cubed, so then we're going to bring the 3 to the front, and then we knock one off the power, which should be 2. And there we are. Cool. Part C then, we now need to differentiate x minus 2 over x squared. Right, okay, so what we can do here, again, it's not really written. It's not really written in the form of x to the n, right? We don't have just powers of x on its own. So I need to split this up. I need to use index laws again. So therefore I can say, well actually I can split the fraction up, okay? You might see questions like this pop up. A good strategy is to just split the fraction up, because then that'd be x over x squared minus 2 over x squared. Then we can use index laws. So actually, first of all, this is basically the numerator. X has basically a power of x to the 1, right? There's a hidden power of 1. Then we can divide the x's by subtracting the powers. So it'd be x to the 1 minus 2, which would be minus 1. Okay? And then we subtract, well, 2, and then this x squared, it's a reciprocal, right? It's 1 over x squared. So I can say it's x to the minus 2. Okay, so there we are. Now these terms are in the form x to the n. We just have a power of x. Now we can differentiate. So then, if we differentiate, well, we bring the minus 1 to the front, so that'd be minus x. Then if we do minus 1 and knock another 1 off, that'd be minus 2. Then we subtract, then we do minus 2, and then we bring the minus 2 to the front, so that'd be times by minus 2, x, and then we knock 1 off. So minus 2 minus another 1, that'd be minus 3. If we then simplify it a little bit, we get minus x to the minus 2 plus, well, minus 2 times minus 2 is plus 4, x to the minus 3. And there we are. Cool. So yes, make sure you are confident as well as the power rule. You're confident in your index laws as well. We looked at that at the start of the course. So you need to be confident how I use index laws to simplify these expressions here. But hopefully that was clear. Okay, we're going to look at some exercises, and I've got some more kind of quick fire differentiations. So now we really look, again, we need to be quite comfortable now differentiating terms like this at this point. So first of all, we have y is equal to 2 root x. I can use index laws to rewrite it as 2x to the half. And now it's just a power of x. So now if I differentiate it, if I then do 2 times a half, because the half's coming to the front, that would be 1. Or just x, right? Then if we knock 1 off the power, half minus 1, that's minus a half. Okay? And there we are. Part B, we have y is 3 over x squared. Well, again, I need to use index laws. So then that's going to be 3x to the minus 2. Then we can differentiate it to get to, well, 3 times minus 2, as again the minus 2, the power comes to the front, that'd be minus 6. Then we subtract another 1 off to the power, that'd be minus 3. And there we are. Okay, part E, we have y is equal to 2 over x cubed, add root x. So again, I can use index law to simplify each term. Now firstly, the 2 over x cubed, that'd be 2x to the minus 3, because it's a reciprocal, so it'd be in the negative power. Then root x, that's just x to the half. Then we can differentiate the terms individually, so then dy dx. Now again, 2 times minus 3, 2 times the power, that's minus 6x. Then we subtract 1 off the power, that'd be minus 4. Then for the second term here, x to the half, we then have a half, x, and then a half minus 1 is minus a half. And there we are. Cool. Part F then, we have y is equal to cube root x, add 1 over 2x. So what I can do here is, well, first of all, we can say cube, remember a cube root is going to be x to the third, okay? Remember, it's not x to the half, because the half is basically the normal square root. If it's a third, then it'd be the cube root, okay? Make sure you are aware of that, right? You paid attention to that. So we can rewrite it as that power of a third, right? That's third there. Then for this bit here, this fraction here, 1 over 2x, I can say is a half, then 1 over x. Okay, and so then that's x to the third. Then this 1 over x again is a reciprocal, so that'd be x to the minus 1. So it's a half x to the minus 1. And now I can differentiate. So then what I can do is I can then do a third x, and then a third minus 1 is minus 2/3. Yes, minus 2/3. Make sure you didn't write minus a third, okay? Be very careful. What a third minus 1 is minus 2/3, not minus a third, right? Make sure you again, make sure you pay attention. With this, you never know, like, make silly mistakes which can be common, which can happen. So make sure we don't lose easy marks on that. Okay, now we have this half x to the minus 1, so that'd be minus a half then, because minus 1 comes to the front, x, and then we subtract 1 to the power, that'd be minus 2. And there we are. Then we have part I, we have y is 2x cubed plus 3x all over root x. Well, my first idea then is to split up the fraction, right? So it's 2x cubed over root x, add 3x over root x. But then I need to deal with the root. I can't have any roots, right? It just has to be x, not root x. I can convert that to an index, right? Because that's x to the half. And x to the half. Then I can divide the fraction by subtracting the powers, right? So it's 2, then x cubed over x to the half. That's 3 minus a half. That would be 5 over 2, okay? And that's that written as an index. Then the second term, that's 3x. And remember, it's a hidden power. What hidden power of 1? So it's 1 minus a half. That would be a half, okay? And there we are. So we got it as indexes. So therefore, when we differentiate, differentiate this. Well, first for the first term here, that's going to be 2 times 5 over 2. That'd be 5x. Then if we do 5 over 2 subtract 1, that'd be 3 over 2. Then for the second term here, we're going to add then 3 times a half. That's 3 over 2 x, and then a half minus 1. That's minus a half. And there we are. And then the last part. We have part J, we have x times x squared minus x plus 2. Well, again, I can't have them times together. I only know when I'm adding them. So I can expand the bracket, right? So then I can do x cubed minus x squared, add 2x, and now this is a form I can differentiate it because it's all in terms of powers of just x, right? Okay, so then dy dx is going to be, well, x cubed. Well, again, the 3 comes to the front, then we knock 1 off the power, so that'd be squared. Then minus x squared, that'd be minus 2x, and then we knock 1 off the power, that'd be 1. So that's just x. Then 2x, well, x goes to 1, so it's just 2. Okay, and there we are. Cool. Okay. Okay, so again, that's kind of how comfortable you want to get to be when you practice enough. Just pretty much quick fire differentiate expressions like that. Okay. Okay, and we've got this question now. We are told f of x is equal to 12 over p root x add x, where p is a real constant and x greater than 0. Given that f dash, remember f dash is the derivative, the f dash of 2 is equal to 3. We need to find p. So what we need to do really is, what is f dash of 2? We know it's 3, but let's try and find what the derivative, right? And then go from there. So f of x is this. So then if we were to compute the derivative, f dash of x, okay, well, we need to simplify some things, right? Because this fraction here is not in the form x to the n. It's divided by root x, so we need to clean this up. So let's simplify. So first of all, we can do 12, we can factor the number out. So 12 over p times by 1 over root x, right? Then we can rewrite this, right? This 1 over root x, so 12 over p, then 1 over root x, that's going to be 1 over x to the half, right? Because then the root x is x to the half, and then this is a reciprocal, so it'd be 12 over p of x to the negative a half. So then we're left with 12 over p x to the minus half. Now we can add x, right? Remember we're adding x as well. Add x, add x, add x. So that's my final expression. They're both now up as powers of x, right? So now I can differentiate. So f dash of x then, if this is f of x, then f dash of x, well, it's going to be, well, minus a half times by my number in front, so 12 over p times by minus a half x, and then minus a half, subtract 1, so we knock 1 off the power, that'd be minus 3 over 2. And then differentiating x leaves us with 1. And there we are. Then we can sort of simplify, right? We can simplify this fraction. Now we don't know p, but we know that this is 12 over p times by minus 1 over 2. That would be minus 12 over 2p. Right, and actually then I can 2 is a common factor because minus 12 is 6 times 2, so I could say that that is minus 6 over p, and then that's minus 6 over p, x to the minus 3 over 2, add 1, and that's my simplified expression for the derivative. Okay, so again, it might look a bit ugly, there's p's involved, but hopefully you've seen how I got to that point. And yeah, so this is my derivative. So then I could say that therefore that f dash of 2, I'll do it up here actually, f dash of 2, if I literally substitute x as 2 into here, I get minus 6 over p of 2 to the minus 3 over 2, add 1. Right. I don't think that will simplify. And so I think we should leave it there. So that means f dash of 2 is equal to 3. So then I can say, if I do it down here now, that f dash of 2 is this. That has to equal 3, okay? So minus 6 over p of 2 to the minus 3 over 2, add 1, equals 3. Okay, so then what I can do is, I can probably firstly move the 3 to the other side, so that I have minus 6 over p of 2 to the minus 3 over 2, subtract 2 equals 0, okay? So it kind of resembles a sort of equation. Okay, what can I do now? Well, I want to solve for p, right? Yeah, I want to find p. So p is here, so what I can really do is actually I should move the 2 to the other side, right? So then minus 6 over p, 2 to the minus 3 over 2 equals 2. And I just want to get p on its own. What I can then do is, well, recognise I have minus 6 over p, the fraction, times by 2 to the minus 3 over 2. I can divide by that, right? So if I divide by this whole 2 of minus 3 over 2 to both sides, I get minus 6 over p is 2 divided by 2 to the minus 3 over 2, right? And then I can simplify actually, because okay, because then what this is saying is actually 2 over 2 to the minus 3 over 2, right? I can use index laws to simplify, right? So minus 6 over p is going to equal, well, 2 to the 1 divided by 2 to the minus 3 over 2. We subtract the powers. So that means it's going to be 1 take away negative 3 over 2. That's a double negative. So that'd be 1 add 3 over 2, right? If I do 1 add 3 over 2, that's 5 over 2. Okay. And there we are. Okay, then I can sort of cross multiply, right? At this point, if you imagine we're then dividing by 1, that's going to be minus 6 is equal to 2 to the 5 over 2 p, right? Then I can therefore divide by 2 to the 5 over 2 to say p is minus 6 over 2 to the 5 over 2. And I don't, and I need to write it in this form, a root 2. Okay, okay, so a root 2, so at that point I'm going to need to probably look at this power of 2 here and see what I can do. What 2 to the 5 over 2 is saying, we have minus 6, then what we're doing is 2 to the 5 over 2 is basically 2 to the half all raised to the power of 5, right? So 2 to the half is root 2. then that's raised to the power of 5. Now, if we then basically, what this is saying is we times this 5 times. So it's going to be root 2 times by root 2 times by root 2 times by root 2 times by root 2. Well, then we can, well, actually, root 2 times root 2 is just 2, right? So that'll be 2, that'll be 2. So basically, we're eventually doing 2 times 2 times by root 2. That'd be 4 root 2. So this is minus 6 over 4 root 2. And so we can simplify, because 2 is then a common factor under the top and bottom. So that's going to be minus 3 over 2 root 2, okay? Then we can rationalise the denominator. So then it's going to be root 2 over root 2. And so that will get me minus 3 root 2 over 2 root 2 times root 2. That's 2 times 2. That'll be 4. Okay, so overall I can say P is minus 3/4 root 2. And there's my answer. Okay, there we are. So now it's in this form here. Okay, we got there. The very tricky question that is. Very tricky. But there we are. So it's basically, this question is just using index laws, really. So this is a really good exercise to really test your index laws. But there we are. Cool. Okay, we're going to finish off with an exam question now. So we are told a curve has the equation y is equal to 3x squared add 24 over x add 2. We need to find dy dx as simplified as possible. Well, before we do that, we actually need to simplify the middle term here, the fraction, because I need it as x to the power of n, not 1 over x to the power of n, right? And no fractions, just x's as powers. Well, I can rewrite this, right? So before I differentiate, I can rewrite this or simplify as 3x squared. Then that'd be 24 of x to the minus 1, add 2. Now I can differentiate. If I do that, I get, well, 3 times 2 is 6x. And then minus, because the minus 1 comes in front, minus 24x. Then we subtract 1 off the power, that'd be minus 2. And then the constant, the numbers go away, they go to 0. So they're not, we don't need to consider any just numbers on their own. And that's it. That is, I believe that should be in simplest form. You could, if you wanted to, again, like I said, you could rewrite this x to the minus 2, you know, as a fraction. So that'd be 6x minus 24 over x squared. That should be, either way you should be fine here. Like I said, that's fully simplified, so I should get all the marks there. Okay, cool. Okay, so that's it for this section. So hopefully now you're quite adept and used to the power rule, how we can differentiate expressions and functions of x like this. Okay, so yeah, I'll leave it there. I'll see you next time.